In this video, I introduce a scientific AI agent, tool-augmented large language models for scientific reasoning. SciAgent is a scientific AI agent that is applied to solve scientific problems by retrieving, understanding, and using scalable toolsets. Namely, its reasoning capabilities enhanced by tool-augmented large language models. There are two methods for scientific reasoning. One, fine-tuning large language models domain by domain, as shown here. Two, fine-tuning large language models on math related to augmented samples, as shown here. When adapting large language models to a specific domain, a domain-specific toolset is attached. No additional fine-tuning is required. SciAgent firstly generates a high-level planning for a given question, and then uses this plan along with the question to retrieve questions from the attached toolset. Leveraging the retrieved functions from the toolset, SciAgent completes the low-level action integrating natural language and segments of Python code. Finally, SciAgent executes the Python code and produces a solution to the question. Given a scientific domain D, tool-augmented scientific reasoning task assumes access to 1, a question Q, and 2, a toolset FD that encompasses a large amount of well-defined domain-specific functions from F1 to FD. The objective is to develop a large language model-based agent that selectively uses the functions in FD to enhance the answering to the question Q, as shown here. This is the question Q. Large language model is used to generate planning GQ and functions FQ tilde. And then train retriever R, and then use this toolset. The retriever R generates this function, so FQ, and then this FQ is used to generate the final solution. Regularly given a question Q and his ground truth solution in a training set, a large language model is used to 1. Generate a high-level planning GQ, 2. Follow the planning GQ to generate functions FQ tilde, and 3. Produce a solution SQ tilde generated by calling the functions FQ tilde. If the solution fails to execute, the feedback is used for the large language model to rectify the errors in FQ tilde and SQ tilde. However, some functions in FQ tilde tend to be ad hoc, and SQ tilde tends to be convised and only fit the requirements of function coding. Therefore, SciAgent disentangles the construction of toolset and function augmented solutions. Given the developed toolset, SciAgent retrieves more generalized functions FQ and generates a more qualified solution SQ. The question Q and the generated planning GQ are used as a query, and the generated function FQ tilde as keys. Dense retriever R is trained on the query key dataset using informal NCE loss as a loss function. Upon the toolset F and the retriever R, 3 functions are retrieved as FQ as shown here. A large language model is used to write solutions that call functions in FQ to generate the solution as a queue. SciAgent comprises 4 modules, namely planning, retrieval, action, and execution. Planning module provides a high-level profile for each question, giving a generated planning. Retrieval module retrieves related functions from the domain-specific toolset. Action module generates the low-level solution by executing snippets of the Python code. Execution module is a Python executor to run the program to generate the final answer as shown here. This question is a planning. It's a toolset with a retrieval. You get this action, and then from this question and the retrieval function to generate the final answer. The large language models are used in planning, retrieval, and action modules. The fine-tuned retrieval R is used in the retrieval module. The planning and the action modules share the same large language model, but fine-tuned using different instructions for planning and action respectively. For more details, please check with these references. Thank you. Bye.